Okay, when you're ready.
Ready? I'm going to give a short talk about my research project. It's not intended to be like a transfer presentation. It is just a very glimpse about what I'm doing. So you won't find any kind of charts, but you will get the main idea, hopefully. The big title of my project, it is going to be a reconfigurable architecture for floating point applications. This complex title is the title of our overall project, and I'm one of the 3 PhD students who are going to work on this. What do I mean by, we have 3 key points in here. We have reconfigurable, we have architecture, and we have floating point. There is a very main family of logic. You can see processors that process all the operations in your computers, and there is something else called reconfigurable logic. So this reconfigurable logic is part of 2 things. We have the logic blocks and we have the connections. And if you see the matrix in here, you will find that there is these small blue squares surrounded by wires. So these small blue squares can implement any function. They can add, they can subtract, they can divide, they can multiply. And these routing logic, they can pass the inputs or outputs from any logic to another. For example, if I would like to implement, I have an input.
How do they pass them?
Sorry?
How do they pass them?
How do they pass them? These logic are reconfigurable, and they can be connected to the inputs or outputs of any logic block. So
Is that straightforward to do?
It is.
Is that straightforward to do?
It is just a click. You do your design, and then you click download your bit stream, and then you connect it to them.
What software do you use to do that?
There are lots of softwares. We have two main companies in here. We have Xilinx and Altera. And these companies, they have a broad range of logic, and they as well as their own software tools. So these tools
are they easily accessible, this software? Do you have a site license?
You can get a licensed version. It's going to support loads of different features, but you can have a demo version, and there are student versions available on the web. So if you are interested, the fun part about configurable logic is that you don't need to have multi-billion foundries. You don't need to be Intel. You don't need to be these huge names. You don't need to be HP. You can be a guy in a very poor country having just $200. You bring the board, you download the software, you do your design, you download it there, and here we go. We have an implementation, we have product, we have a chip, we have a processor, for example. So we talked about the logic and the connections. And if you do the logic, and if you decide the connections, we have an architecture. So I summarized what is a reconfigurable logic and what is an architecture. So we can implement any function in here. It is programmable like software. If any of you had an experience programming throughout his study, then he can understand how simple it is. And it's just, you have a program, click on that button, done, here we go. The strong point is that Alex mentioned that he needs for his experiment 3 months on that huge, very expensive cluster that they have in their labs. I can assure you that if you have a cluster of these reconfigurable logic, we can reduce this 3 months to days. As an example, if you have a very fast runner and you would like to move amount of bricks from one location to another, and you have 2 options. You have one builder, and he's extremely fast, and on the other hand, you have 4 builders that are slower, but they are working in parallel. So the fast one simulates your cluster, or emulates your cluster, and the slow ones, but who work in parallel, represents my configurable logic. And that's for sure. It is pretty obvious that the 3 slow ones are going to move the bricks from one location to another faster, even though they are doing less effort, that fast builder is going to burn down. But these people will still have more energy. So people argue that the computing future is going to be this in this family of logic. Yeah. So the overall project goals is to try to design classes of architectures, different connections, different logic blocks, sorted out in different ways, in order that targets your kind of applications, that targets physical applications, biological applications, financial systems, in order to speed them up from months to days, probably hours. I have an example in here. If anybody of the audience have a physics background, probably will know what is an in-body problem. Most of us, or a lot of scientific community, use Monte Carlo simulation for different sort of things. These are just examples, they're not part of my project. So for each architecture, for each kind of logic blocks, and for each kind of connection, of each kind of connection networks, there is the power consumption, and there is the area used for the design, and there is the performance of that architecture. So the target is to try to have a class of designs, and for each class of designs to have a function, a model for its area, a model for its performance, and a model for its power consumption. To give an example about how eminent the power consumption, in 2002 or 2003, Intel, one of the high officials in Intel, he said that the processor power density in 2005, it's going to be like a jet engine. In 2007, in 2010, it's going to be like a nuclear reactor. And 2020, it's going to be like the sun. So you can imagine how much power these small devices consume and how much heat these devices generate. So it's extremely important that this gives you an idea about how important these designs are. So to give an example about my own work, I'd like to present this kind of algorithm. It's very simplistic. You don't need to have any background, any computing background. So I have a problem. The problem is I have an application. I would like to understand which part of that application will need the more computing power. In your example, I will be taking your whole model of the jet engine materials, and there will be parts that will take 50% of the processing time, probably 70%, and I need to identify these automatically. In our example, we have two main operations. We have y equals x1 plus x2, and then we have a loop, another operation that is going to be operated n times. And it contains a division, it contains a multiplication, and it contains an addition. Intuitively, you can say that E equals this whole equation is going to be performed n times, while y equal the only plus, is going to be performed one time. And we can...
1 minute?
Yeah.
1 minute. 1 minute remaining.
1 minute remaining. So, so my task is to identify that the second operation is going to be the more time consuming, and hence the logic function should represent that equation. Another thing, how should I implement the function? I have two examples in here. In the first example, I have 1 multiplication, 2, 3, 4, 5 multiplications, and 2 additions. If I just change the presentation of this equation, it's going to be 2 additions and 2 multiplications. So you can have an idea about the speed up in here. The research results should contain a set of algorithms that will pick up the best implementation for a given application under a certain set of constraints. and a set of algorithms that it's going to identify the possible functional units in an architecture. And thank you very much.
Thank you. Okay, just give people a minute so just to finish off there.
Can you ask questions?
Yeah, please ask questions.
Sorry, questions.
I know it is
yes,
complex,
yes.
it's a little bit non-humane,
Questions.
so I do understand this.
What is a
So
logic?
please, what is
A logic.
a logic? A logic is, it's like philosophy. 1 + 1 = 2. 1 means true, 0 is false. This is logic. As simple as that.
How do you mean it?
You didn't
We're
get it.
talking about a logic as a piece of hardware.
Yeah, it is the same. It is the same. Okay, in the computer it has a different language. Usually when we went to school early, when we were kids, we started learning addition. And the way we learn it is that, we have one banana on one hand, another banana, and you add them together, there are 2 bananas. But the computer doesn't understand it this way. You can't tell the computer you have 1 banana on your right and another on your left, and what is the result? Computer has a different representation of life problems. And it depends on 2 main numbers. 0, false, 1, true. So the 1 can be represented, let's say the one that we understand, the banana, or the 2, can be represented using only 0 and 1. And this is logic.
So a logic, as you were speaking here, is basically an array of transistors.
But people in here don't know what is a transistor.
No, me too.
Some of the people. It is a mix of transistors that is designed to implement functions. But what you need to know as an audience in here, it is as simple as that. You have a black box, and you can click that button, and you can have your application implemented. But you need a digital design.
Okay, thanks. In the interest of time, I'm going to stop.
Yeah.
Okay, so general feedback.
Very simple feedback. Can I hear it? A red with dark blue.
Doesn't work.
Well, it sounded interesting on the computer.
Yeah, no, okay.
I mean, stand back and look at it for yourself. It's
That
just
formula.
doesn't work.
So it was that.
Well, see if you can see what you think.
No good.
And the formula,
Wow.
particularly if there's a slight glare on the screen, it's gone. Yeah. I know it's a standard college colour, the background.
Yeah.
But then you've got to really go for bright, very light pastels or white. Bigger font size as well. Yeah. What happened with the questions when I was asking you questions?
I really like them because it's obvious I wasn't clear,
Okay.
and you made me more clear.
What do others think?
I think so.
It interrupted the flow of the talk, I think.
But I was ready,
I could have gone on for half an hour.
and I could have
Yeah.
gone for.
But you got 10 minutes. You got 10 minutes. Yeah.
So what should I say?
Well, careful. If you get one question and you think, yeah, that's relevant, I'll answer that. But if the person's persisting, then just say, can we leave questions to the end? It's up to you. You're in control with it.
So I thought it's like a competition.
Or-
Who ask me? I'll give you the answer.
Quite often when people come in fact, they're thinking logically, and you're going to answer it a bit down the line. So, and then if that happens, just kind of say, bear with me, we're going to answer. I'll come to that. Yeah, if I don't, we'll come to it at the end. When you answer the questions, I mean, if you answered Alex's question here, again, you could have gone on for a long time. So,
Yes.
and he said, logic is, as though he hadn't taken on board. In fact, what he was saying, I have one. So keep it kind of short, sharp, yeah, and unless it